In question 1a, we're asked to define the electric potential at a point in an electric field. Well, this is defined as the energy transferred per unit positive charge to move it from infinity to that point. In B, we have part of the region around a small positive charge showing distances and points labelled with the letters L, M and N. In part 1, the electrical potential at point L due to the charge is plus 3.0 volts. We need to find the magnitude Q of the charge, giving our answer to an appropriate number of significant figures. Well, potential is given by charge over 4 pi epsilon naught r. So rearranging for the charge, putting in the values, gives an answer of 1.0 times 10 to the minus 10 coulombs. In part 2, we need to show that the electric potential at point N due to the charge is plus 1 volt. Well, we can again use this expression. Putting in the values gives an answer as Putting in the values gives an answer of plus 1.0 volts as required. In part 3, we need to show that the electric field strength at point M, midway between L and N, is 2.5 volts per meter. Well, electric field strength is charge over 4 pi epsilon naught r squared. Again, putting in the values gives 2.5 volts per meter as required. In C, we have R and S, two charged parallel plates 0.60 meters apart. They're at potentials of plus 3 volts and plus 1 volt. In part 1, we need to sketch the electric field between R and S, showing its direction. Well, this is R and S, and the field will be uniform and downwards like this. In part 2, point T is midway between R and S. We need to find the electric field strength at T. Well, electric field strength is given by potential difference over distance, and this gives 3.3 volts per meter. In part 3, we were told that parts B In part 3, we're told part B3 and C2 both involve the electric field strength at a point midway between potentials of plus 1 and plus 3 volts. We need to explain why the magnitudes of the field strength are different. Well, the first part involved a point source. This produces a radial field, which weakens as we move away. The second part involved a uniform field.